Okay, almost every introductory geology course trots out this guy. This is poor old James Ussher, Archbishop of Armagh in Ireland. Those are his dates there. And the reason he gets brought up when we talk about the age of the Earth and things like that is because Ussher made this bold claim. He said the date of creation was 9 a.m. on Sunday, October 23rd, 4004 BC. This is when the Earth was created. Now, you know, a professor will show a picture of Ussher and show his claim and have a big laugh. Ha ha ha, we know the Earth is actually 4.6 billion years old. But really, Ussher wasn't a crackpot. He was a scholar. He was a pretty serious scholar. What he was trying to do was come up with a timeline, a history of the Earth back to the time it was created. And he was pretty good when he had historical documents and things to correlate and come up with dates. So, you know, the assassination of Julius Caesar, the reign of Alexander the Great, things like that. He was pretty good. He put together this nice timeline with some pretty accurate dates. But the problem is, once he got so far back and you don't have enough historical records, he really didn't have enough data to be accurate. Now, how he came up with this very precise prediction of 9 a.m. Sunday, October 23rd, 4004 BC, I don't know. But because he was a well-regarded scholar, this assumption kind of stuck. And later scientists started out working with this assumption that the Earth was a few thousand years old. Now, when we get to the Enlightenment, so we get into the late 18th century, early 19th century, this is when we had sort of the first Enlightenment scientists, and they called themselves naturalists. They were maybe the first early geologists, and they were looking at rocks, they're looking at landforms, they're looking at fossils, just trying to figure out how the world worked and the history of it. And it became apparent that the Earth couldn't be only a few thousand years old. We needed more time for any of this evidence that we're seeing in the rocks to make sense. Now, one of the first people to advocate this, what we call the principle of uniformitarianism. Uniformitarianism is the idea that the present is the key to the past. So if we look at things that happen in the present, we can understand the past. One of the first people to articulate this was James Hutton. And he was working in the late 1700s. Basically, Hutton was looking at rocks and looking at fossils and things, and said that, well, if we can measure things that happen now, right? We assume that everything that the forces that are at work today were at work in the past. So gravity worked the same way, streams eroded and deposited sediment the same way, and so on. So you could measure things like, well, how much sediment is eroded off a hillside, how much sediment is carried in streams, how is it deposited, and so on. And Hutton was one of the folks that appreciated that this is a very gradual process. The Earth is constantly, landforms of the Earth are constantly being torn down by erosion and built up by other forces. And when you look at the evidence, you look at fossils, you look at the rates of movement of sediment, that the Earth can't be just a few thousand years old. It must be older if we're to believe the physical evidence. Okay, so this is what we're working with now. This is called a geologic column, and this summarizes, basically 200 years of geologic research, putting together a history of the Earth, right? So geologists poking around all in different places all over the Earth, looking at rocks, comparing rocks from different places, fossils, and so on, and putting them in a relative order, right? What came first? What came next? What came next? The other thing on this geologic column is you can see there are actual dates here. There are years. And we'll talk later in the course about, well, how do we figure out those actual years, right? How long these periods of time are. But we'll talk about radiometric dating and things like that. But basically, this is a great device that summarizes basically all we know of the history of the planet. So of course, this is like if you had a rock cut or a cliffside or something like that. As we go down, the rocks get older, right? So young stuff is at the top, and old stuff is at the bottom. We have different divisions here, starting with the most coarse divisions. We've got eon, and then we get finer divisions. We've got era and period and epoch. epoch is, mostly just, we're talking about these recent things up here. Now, let's talk about eon first. So we've got sort of two broad eons, and that's the Phanerozoic and the Precambrian. If we look over here, this is the relative time span. We see that the Precambrian is very old, very long, and the Phanerozoic is much shorter, right? So the Precambrian, the dates are in tiny text right here. So this is 4.6 billion, right? This is 4,600 million is the units there. So 4.6 billion to about 550 million years ago. That's the Precambrian. That's a big chunk of time from the formation of the Earth until the boundary between the Precambrian and the Cambrian. But we don't know a lot about the Precambrian, right? It's old. Most of those rocks that were formed at that time have either been eroded into sediment and formed into new rocks, or they've been metamorphosed, and metamorphic rocks have been altered, and it's tough to see, exactly what was going on. So there's not a lot of evidence, or the evidence is much more sparse regarding what was happening on Earth during that time, right? Know some things, but not nearly as much as we know about more recent rocks. So that's why we kind of blow up on this left side of the diagram, why we blow up the Phanerozoic, because we know a lot more about it. Now the Phanerozoic is divided into 3 eras. So era is another division of time. And we have the most recent is the Cenozoic era. Then we have the Mesozoic, and older than that we have the Paleozoic. The Greek roots of those words, right? Paleo is old, and zoic more or less means life. So old life, Paleozoic, middle life, Mesozoic, and recent life, Cenozoic. Right? And those are based on the fossils that you find there. In this epoch column down here, we can see that in the Paleozoic we first start to see fossils of invertebrates, then we start to see fishes, then we start to see amphibians. Then we get to the Mesozoic, and this is the age of dinosaurs. So here it says age of reptiles. We're talking about dinosaurs and birds. And then in the Cenozoic, we're talking about mammals, everything since the extinction of the dinosaurs. Right, so the eras are mostly based on fossils. Now, period is really the one you should focus on, and you should spend some time studying the geologic periods and the order that they come in, and the rough, you should have a rough idea of when we're talking about in terms of millions of years ago. So there's a little mnemonic device that I use, starting with the Cambrian, right? So the Cambrian period. If you take the first letter of each of these periods, you can make a cute little sentence. So starting with Cambrian, I'll say, camels often sit down carefully, perhaps their joints creak. And that gets you through the Mesozoic, right? Camels often sit down carefully, perhaps their joints creak. And that takes you through Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian, Triassic, Jurassic, Cretaceous. It's worth noting that the Carboniferous is sometimes split up into 2 periods called the Mississippian and the Pennsylvanian, but I couldn't figure out a sentence to incorporate those, so just use Carboniferous. And then in the Cenozoic, you'll just have to remember, don't use the term tertiary, that's kind of outdated, but Paleogene, Neogene, and Quaternary. And if you study this diagram, you can see that for instance, the Quaternary, we're talking about everything in the last about 2.5 million years. For instance, the Cretaceous is everything from about 150 million years ago to when the dinosaurs go extinct about 65.5 million years ago, right? So it's worth studying these a little bit to make sure you kind of have the order down and have a rough idea of the dates. Because we'll be throwing around terms like, oh, here's a Paleozoic limestone, here's a Cretaceous sandstone. You should have some idea of these different periods and when they occur relative to each other and about when we're talking about them. Here's another cartoon, and it's basically the same thing. And I don't want you to get too hung up if you look here at these dates. Here's those calendar dates, and again, we'll talk about radiometric dating and how we arrive at those dates, but they always change a little bit. We always get more information. We get better radiometric methods, we get better fossils, we get better molecular evidence from rates of evolution and things like that. So these dates always shift around a little bit. So memorizing these down to a very fine scale isn't really necessary. But let's say if we're talking about the Jurassic, you should know just off the top of your head that we're talking about between about 200 million and 150 million years ago. And you should know that, well, we've got dinosaur fossils in there during Jurassic time, that it's before the Cretaceous, where we have other dinosaurs, right? We have in the Cretaceous we had things like T-Rex. In the Jurassic we didn't have T-Rex yet, but we had things like Stegosaurus and Allosaurus, those sorts of things. And you should know the Jurassic is after the Triassic, and that it's in the Mesozoic where we had dinosaurs, right? So it's worth knowing something about all of these periods and what kinds of things you would expect to find there. And in the beginning of your book, if you have the Roadside Geology of Colorado, the first couple of pages is a geologic column for Colorado. So it has all of these geologic periods and then what's going on in the western part, the central part, and the eastern part of the state. It's definitely worth spending some time reading that over, thinking about it. So when we go on our trip, you'll get a feel for, oh, wait, these are Paleozoic rocks, these are Mesozoic rocks, and so on, and what's going on, what has gone on in the history of Colorado. So here's just an example. So if we're at Colorado National Monument, which we will be stopping at on the trip, there's some really great sedimentary rocks there. In your book, we'll have something like this, a geologic column, something like this. It'll have a geologic column, and it'll give you the names of the rocks, the local names for the rocks, right? And then you'll have, the relative order of these things in the column. And then you'll also be able to figure out in your book, we'll have information on it, and we'll be talking about it. Okay, what was going on? So for instance, we have the Mancos Shale here. What was going on to deposit that layer? What was Colorado like? And we would know that at that time, in the late Cretaceous, we were under the ocean, right? So these are ocean deposited sediments creating this really thick layer of shale. So this is the essence of what we're going to be doing on the trip. We're going to be going around to different places, looking at the rocks and seeing the evidence of what was going on at these different points in time. It's really fascinating, and I think it's well worth some study beforehand, so when we get out there, we'll get that much more out of it.